Hi, geometry people. So we're continuing our dilations lessons in Investigation 1. We already did lessons 1 and 2. Now we're doing lessons 3 and 4. And we're going to start on page 31 in the book. And we have some tasks here. We're going to draw, or I'm going to draw for you, some triangles so that we can compare the measures of the angles and the sides, and we can see what the rules are and what the theorems are about triangle similarity. So you may recall that we talked about in the last lesson that when two polygons are similar, when they are a dilation, their corresponding sides are proportional, which means they have the same scale factors. But the corresponding angles are congruent, which means they have the same measure, the same number of degrees. So in our first task, which in other times you would be doing in partners, but because we are where we are in this time, I'm going to do it for you as a demo. We're going to draw a couple of triangles, and they gave us a couple rules. They said that we're going to draw a triangle that has an angle at point A of 35 degrees and an angle at point B of 60 degrees. And we're just going to draw two different triangles. Okay, so those are our conditions. So here's what I'm drawing here. I'm starting with a side AB that I've decided to make 10 centimeters long. So here's a 10 centimeter side. And I know that angle B has to be 60 degrees. So I can measure with a protractor 60 degrees, and I put a little mark, and then I connect them to draw the side. Okay, and I know from point A I need a 35 degree angle, so I can do exactly the same thing. Draw a 35 degree mark, connect those, and where the lines run into each other, that is point C. Okay, so there's our triangle. All right, we're going to do the same thing with another triangle, but we're going to make the base 20 centimeters long, so much longer. And I'm going to do exactly the same thing, okay? So I'm calling this one A prime, B prime, C prime, because it's going to be, hopefully, a dilation of the other triangle. So we're starting with a 20 centimeter side. I need a 60 degree angle at this side, at this point. There's my 60 mark. From this side, 35 degrees. There's my 35 mark. I think I need a bigger ruler. Okay, it's a big triangle, 35 degrees. Goes up like that. Gotta connect it. There, and there's our C prime. Okay, so we know those two angles are 60 and 35. 60 and 35. What would the last angle have to be? Well, they need to add up to 180, right? So we need 180 minus 60 minus 35. And if we do all that, that last angle has to be 85 degrees. Okay, now what about the sides? We know that this was 10. Let's measure the other sides. Okay, so using the ruler, these are centimeters. So using the ruler to measure the centimeters out, this is 5.8 centimeters. And this one is 8.7 centimeters. And if I measure the larger one, bigger ruler, bigger triangle, this one is 11.6 centimeters. And this side is 17.4. Okay, so we can calculate our scale factors. Let's compare corresponding sides. So this is the shortest side, and this is the shortest side, BC and B prime, C prime. Okay, so those are going to be 11.6 compared to 5.8. Okay. The base sides AB, A prime, B prime, 20 compared to 10. And the medium sides are 17.4 compared to 8.7. All right, in every one of these, that is the same scale factor of 2.0. Okay, times 2, every one of them. All right, so the important thing that we can see from that is, I've already filled the table out for you, all the sides have the same scale factor, 2.0. All the angles are congruent. They all have exactly the same measure. We found angle C by subtracting the other two angles from 180. Okay? And those two triangles were different measurements, but they were similar. All the sides had the same scale factor of 2.0. Now what they gave us was two angles and the side in between. Okay? So we could call this angle, side, angle. Okay? Actually, we didn't even need the side. We could have made the side whatever we wanted. So all we really need is angle, angle. Okay? So angle, angle gives us enough rules to make similar triangles. Okay, let's go on to task number 2 on the next page. All right, so task number 2, they're going to give us just 3 side measurements. They're not giving us any angle measurements at all. Okay, and they're telling us triangle ABC has one side that's 4, one side that's 3, and one side that's 2. And I'm going to show you how we can construct that. Here's AB with 4-inch side, right? Now we need side AC that's only 2 inches. This is called a compass. And what I've done is I've set the point and the pencil on the compass to be exactly 2 inches apart. You can see that that measures exactly 2 inches. So this is why I'm doing that, because to find this side to be 2 inches, if I start at point A with the point, the needle, and I draw an arc like that with my pencil, every point along this arc is exactly 2 inches away from A. I don't know which point is the correct point, but I know that from point B, it has to be 3 inches. So you know what I did? Here's a compass that's exactly 3 inches. So I can use this to measure from point B. Here are all the points that are exactly 3 inches away from point B. And you know what? This one point where those two arcs cross, that is the only point that is exactly 2 inches from here, and it's on this set of points that's exactly 3 inches from there. So that is the point. That is point C. Okay, and we can check. You can see it's exactly 3 inches. And from A, you can see it's exactly 2 inches. Okay, so that's 2 inches. And that's 3 inches. All right. We can do the same thing. Here's my 3-inch. Okay, because they told us that this one should be 3 inches. Okay. And from the other side, it's supposed to be, how long is the other one supposed to be? What did it say? 4.5 inches. Okay, so let's just see from here. If I want to go 4.5 inches from E, do this a shortcut way. 4.5 inches is going to be right to there. Okay, so there's 4.5 inches. There was 3 inches. Okay, so here's 3. Here's 4.5, and let's see the scale factors. Now this time we didn't know any angles. All we knew were scale factors, okay? 6 inches compared to 4 inches. That's our longest side. DF is 3 compared to 2, 3 over 2. And the other side is 4.5 compared to 3. Every one of those has the same scale factor. 1.5. Okay, let's check the angles. Okay, if I measure this angle, it is 46 degrees. If I measure the angle on the little triangle, it is 46 degrees. If I measure the angle here, it is just shy of 30. It's 29 degrees. And if I measure the one up here, the same corresponding angle, it's just short of 30. It's 29 degrees. And that would mean that the third angle would also be congruent. And here are your numbers. We have 2 angles of 46, 2 angles of 29, 2 angles of 105. So all our angles are congruent, right? We already knew that all the sides had the same scale factor. Okay. So we know we constructed 2 similar triangles. It's a dilation. The only rules we were given were the 3 sides. We were not told any angles. So we could call this side, side, side. If we have all 3 sides being proportional, it will give us similar triangles. It will give us a dilation. All right, let's go on to task 3 on the next page. And here's task 3 set up for us. Task 3, what did they give us for rules? They gave us a side. Let's see, they gave us an angle and 2 sides. So they said let's have triangle ABC, and we know that side AB is 6, and we know at B there's a 35-degree angle, and the other side BC is 4 inches. Okay, so here's 6 inches. We know this angle has to be 35, so let's measure 35 degrees. Okay, and we can make a mark. We know that's 35 degrees. Okay, now we know this side has to be exactly 4 inches long, so we can measure that with our ruler. As long as we go through that point that we know is the 35-degree mark. And we have to go how far? We have to go to exactly 4 inches, which is up here. Okay, so there's our 4-inch side. We don't need to measure anything for the last one. We already know this is the point, and we know point A. We can just connect those. And that's our triangle. Okay, so there's triangle ABC. And if we want to measure this last side, we can measure it, and it's 3.5 inches. Okay, so now let's draw the other triangle. The other triangle, they told us, is going to have that same angle of 35, but it wants that first side to only be 3 inches instead of 6 inches. So here we go. 3 inches. We need a 35-degree angle. That's right here. But we only want this side to be 2 inches long. So from point E, we have to go to that mark where the angle measure was, but we only want to go exactly 2 inches. So that's right there. Okay, so that's exactly 2 inches. So that's our point right there. And then we connect that back to point D at the bottom. And there's our triangle. Okay, and we know this is 2 inches because we measured it. So let's see how long this other side is. What do you think it should be? 3 is half of 6, 2 is half of 4. This one should be half of 3.5, right? And it is 1.75, which is half of 3.5, okay? We could measure all the angles. they should be the same, right? If these are similar triangles. Well, let's see. There's a 40-degree angle. Let's check this one. 40-degree angle. Let's see, that was a 35, and we know that's a 35 because we measured them. And that means the third angle would have to be 180 minus 40 minus 35, which is 105 degrees, okay? So once again, we know these are similar triangles. All three sets of angles are congruent. All three scale factors are 1/2 or 0.5, right? 3 compared to 6 is 0.5. EF, that's F up there, is 2 compared to 4, which is 0.5. And the last one is 1.75 compared to 3.5, which is also 0.5. Okay? Here's all your numbers filled in on your table. Okay? All your angles are congruent. All your sides have the same scale factor of 0.5. Now, what did they give us for these triangles? They gave us two sides. They gave us the two sides with the included angle, right? Remember from your triangle congruence, we could call this one side, angle, side, because they gave us the lengths of two sides and the angle in between the sides. And as long as those sides are proportional and the angle is congruent, we are looking at similar triangles. Okay, so I want to show you how to apply these if we wanted to solve some problems, okay? So on page 46, we go on to page 46 and we use the side, side, side similarity theorem. Look at problem number 7. Problem number 7 says we have to figure out if these two triangles are similar. Remember, if they're similar, they should have the same scale factor. So that's all we have. We don't know the angles, but we have all the side measurements. All we need to do is compare the sides. So let's compare the shortest side to the shortest side. That's the easiest way to figure out what the corresponding pairs are. Shortest to shortest, longest to longest. So our shortest side and our shortest side are 24 and 16. So we can compare those. We can write a fraction, write a ratio, right? So we'll compare 24 to 16, and that's 1.5. Then let's do the medium sides. 33 is the medium side. 22 is the medium side. 33 compared to 22 is also 1.5. And unless they're messing with us, the longest side, 36, compared to the longest side, 24, 36 divided by 24 is also 1.5. So triangle XYZ is similar. Similar is the wave without the equals. Remember, congruent had the equals bars with the wave. Similar just has the wave because they're not equal, right? Triangle, and instead of XYZ, it's going to be UVW because of side, side, side. Okay? Let's see if we've got time to squeeze in one more problem. Okay, on page 49, this one looks like a proof, but I'm not going to really do it like a proof. I just want to show you, okay? So on this one, you guys, let's do the angle, okay? This is tying out some old stuff that we remember from before, okay? They're telling us that these two angles are perpendicular angles, 90-degree angles. That means these are parallel lines. That's important, okay? So AB and ED are parallel lines because I want you to remember when we had parallel lines with a transversal? What do we know about these angles? Remember what kind of angle pair that was? That was an alternate interior angle, right? So this angle here and this angle here are alternate interior angles. And they're equal, they're congruent, okay? What they want us to prove is that this triangle here, ABC, is similar to DEC, this one here. So I outlined them in colors, right? Well, listen, if we know these angles are congruent, so I'm going to say angle ABC is congruent to angle DEC. How come? Alternate interior angles, right? We remember that? Look at what else we have here. We have two lines that cross, that intersect. Do you remember these angles? What are these called that are right opposite each other? Angle ACB is congruent to angle ECD because they are vertical angles, my favorites. And you know what, you guys? That's all we need. Triangle ABC is similar to triangle DEC because of all we need. Angle, angle. And we've proven it. We've figured it out. Okay, so that's it. You're going to go back to whiteboard chat and do some practice and some discussion. Bye, guys.